In this video, I want to have a look at further absolute value graphs, so more complex ones as opposed to your more basic ones. So what we're having a look at is if we're given a function y equals f of x or its sketch, then we can sketch the absolute value of that function. We can sketch f of the absolute value of x, or we can sketch the absolute value of y equals our function. So we're going to have a look at an example of each of those. Let's start with this first one. Sketch the absolute value of our function. Everything above the x-axis, so everywhere we have our positive y values, is going to stay exactly the same. And that makes sense because when you take the absolute value of something, you're making it positive. If it already is positive, it's just going to stay the same. If it's negative though, so everything below the x-axis, that's going to get reflected to be above the x-axis. So it's going to have the same magnitude, so if it was -4, it's now going to be 4. Same magnitude, same size, different direction, different sign. For example, what we've got sketched here is the function y equals x minus 1, x minus 3. What I'm going to sketch now in blue is the absolute value of that. So like we said, everything above the x-axis is going to stay exactly the same. It's a bit hard for me to trace on here, but we're trying to trace exactly the same as we go above the x-axis. And everything below the axis is going to be reflected above. So instead of coming down here, our function is going to come up like this here. All right, so exactly reflected from what's underneath. All right, our second example, we're going to have a look at sketching y equals f of the absolute value of x. So that means that everything to the right of the y-axis, so all our positive x values, that's going to stay exactly the same. But everything to the left of the the y-axis is going to be deleted and it's going to be replaced with a reflection of everything to the right. The reason that happens is if we're looking at this function here, we're taking the absolute value of x. Remember, the absolute value turns something positive. So if we're already looking at positive x values, then our function is going to be exactly the same. So that means anywhere our x values are positive, so from here across, it's going to stay exactly the same as our original function. Again, now this should be exactly on top, but it's a bit hard for me to trace it. Okay, so for all our positive x values, it's exactly the same as our original function. Now, when we drop into the negative x values, if we put, say, a -1 or a -2 in here, it's going to turn that x value positive and spit out the same value it would have if we put in that positive x value. So that means that this is going to be reflected across our axis. So it's going to go through -1 and -3 because it went through 1 and 3 here. And then we're going to come down here. So it's going to be a perfect reflection. Mine's not very perfect, but it's going to be a perfect reflection of what's over to the right. Okay, got one more example. This type of function is when we've got the absolute value of y equals f of x. So if we're having this, we only really care about the positive y values. So that means that everything above the x-axis, so where there's those positive y values, that's going to stay exactly the same. But everything below the x-axis, where the y values are negative, that's going to be deleted. And instead, it's going to be replaced with a reflection of what's above. So if we draw this in green, we're going to have that's erasing. We're going to have exactly the same above the axis. So again, I'm trying to trace that bit. So these two parts are going to stay exactly the same. But what's below the axis is going to be replaced by a reflection of that. So we're going to end up with a curve that's coming down here. So it's a reflection of what's above it. Okay, now two things before I show you what these actually look like on a graph where it's a little bit less confusing. One is that whenever you're looking at this one, often the result of this is not a function. It just becomes a relation. So not a function. That's not always the case, but almost always. All right, and the other one is that when you do this one, that's always going to give you an even function because it's always going to be reflected across that y-axis. All right, let's have a look at what these look like with some graphing software. Our original function here, if we graph the absolute value of that, so y equals the absolute value of f of x, it's going to turn out looking like this blue one here. So you can see that everything above the axis was the same, but what was below is reflected above. Right. If we then have a look at if we're taking the absolute value of f x, so f of the absolute value of x, that's going to look like this. And the last one was the absolute value of y equals f of x, and that's going to look like this here. All right, so that's having a look at some more complex absolute value graphs.